on the glasses. That's going to be one group. And another group is going to be making vibrations with these containers. And there's going to be rice on top. And you have to tell me what is different about when you hit it harder and when you hit it softer. Alright? So easy. Thank you for being very paying attention and raising your hand the whole time. Try and tap this can and make sound and make vibration so that this rice will move. We can do that.
I know! Nino! Tony!
If you hit that pot very hard, a lot of vibration comes down. If you hit it soft, only like 3 grains jump.
Why did it move more? Why did it move more?
Because there was more vibration coming out of the bottle.
Ah. What's the difference between the sounds?
When you hit this one, the water, the air doesn't have any space. But when you hit this one, it gets higher because there's space.
There's more space. And what is that space called? Do you remember? What is the space that the sound...
Vibration.
It is a vibration, but what does the sound travel through? What does the sound travel through? Does anyone remember? What does sound travel through?
Air, solid, and liquid. So it couldn't...
Yes. Hey. So what did you observe?
The sound changes when the cup, like when it has more water or less water.
More water, less water. When you have less water, what type of sound does it make?
Higher sound.
A higher sound. And how about when you have more?
Lower.
Why do you think? Why? What did you think? What did you come and tell me? Why do you think that this one has higher sound and that one has a lower sound? Because that has more weight?
Yeah.
Do you think it has to do with weight?
The more the water, the less the vibration, so the sound goes lower. For example, go ahead.
Tell me about what's the difference between this one with not a lot of water and this one with a lot.
I know.
Tell me.
The difference is, since in this one there's going to be a lot of air, the vibration can go higher. And there's more vibration.
The sound is higher.
And less water. Basically because it has a lot of water, it'll tap lower. The more the water in the cup, the less space for it to vibrate. And since the higher goes like longer, the lower note, it makes it there's less space for it to travel. So it sounds lower. So it doesn't have enough space to get higher.
people. Donna and...
I was with her.
Very good. What would it look like if you had a loud sound? Now, I don't want to hear wicked loud sounds, but why don't we clap? Let's clap. Clap. All right, what changed in the sound wave? What changed? What happened when you were quiet? Do quiet. Quiet. Now do loud. All right. Vibrating sound?
Wait. So, I wanted to show you something. Like, literally.
That's his food.
You also see the vibration is actually going through. It's actually going through the string. Because if you look really closely, when you hit it, and I go really straight, you actually see it move.
So, what's the medium that this sound is traveling through?
The air.
When you hit the hanger or the spoon without putting the string to your ear, what happens?
You just hear a little, but when you do next, you can feel the vibration.
Right. All right. What happens when you put the string to your ear?
You get vibration.
You get the vibrations.
Of this, it's traveling through the string.
All right. It's traveling through the string. Where is the sound traveling when we just hit it without putting the string to our ear?
It was just traveling the string to the air.
The string to the air. Exactly. So what are those mediums? What are those mediums?
String and air. Solid.
The solid and
Gas.
a gas. Because what is air?
Gas.
Air is a gas. So how could we make our sound travel through another medium? What other medium? We could put it in the water, right?
The string to your ear, you can hear it better because it's connected. So it would go like this. And then in.
All right, Charlie, you have another. Oh, you have an answer? I'd like to have a really focused audience to listen to what they're saying, all right? If you have a question during it, or if you have a comment, hold it until the end, and then we'll talk about it at the end, okay? Raise your hand. All right, so I'm narrating. 4 third-grade students are out at recess playing a game when suddenly they hear a noise. Go ahead.
Do you hear that? What is that sound?
It sounds like something is hitting a big drum in a band.
Sound.
Well, sound is a form of energy that you hear, but what I want to know is how do we actually hear sound?
I know that one. When that big drum gets hit, it vibrates, which means it moves back and forth. All sound is made by vibration.
Okay. So the drum vibrates. How come I can hear it?
Well, when the drum is hit and it vibrates, it creates sound waves, which move in all directions so you can hear it.
Oh, so the noise is made by the vibration and not your ear?
Not exactly. Your ear can't really hear noise. It hears the vibration. Your ear collects vibration and they travel through the ear canal to the eardrum, which vibrates.
Oh yeah, I remember learning about this. There are 3 little tiny bones in there. These bones are called the hammer, anvil, and sclera.
Oh, right. It's all coming back to me. The 3 bones being to move. They pass the movement to a liquid in the inner ear, which is a part that shaped like a snail. The part that looks like a snail is called the cochlea.
Right, the moving liquid makes tiny hairs move too, which as the along a nerve in each ear that goes through your brain to tell you what you heard.
Wow, that is cool. Did you just say I have a snail in my ear?
No, it's a cochlea.
Wow.
Where do the signals go? Great. That's how we talk. And I have another question about something you said. You said it sends signals. What did we learn about the body?
Nerves. These are nerves to the brain. I know something.
If you're gonna be up here, I need you to sit down so other people can see. Sit down. Sit in your seat. What else do you remember?
So my experiment is called the chicken experiment. Chicken sound machine. I made it with a paperclip, a string, and a cup. My challenge was to try it with different strings to hear how different it sounds. And it actually
A sound machine. Do you have a name?
No.
No? All right. Show us how it works. Show us how it works.
Wait, I need it in the over here. Oh, I can put it up there.
Sorry.
Just to be tight.
Very good. All right, tell us about how this creates sound.
It's the vibration of the string, and
It's the vibration of the string, and is it a low pitch sound or is it a high pitch sound?
it's kind of a low. It's kind of like cause that's how you hit it. Yeah, cause the volume goes high when you hit it.
Right. Just like we learned with our sound waves, when it goes really far back
Yeah.
and forth, like when you pluck it really hard back and forth,
Yeah.
it's louder.
Goes high.
Right. Very good. Did you want to read any of your...
Sure.
All right.
The sound machine produces sound by the vibration of a string. By pulling the stick, I can make the string tighter. When I do this, the sound machine gives a higher pitch. But if I want higher volume, I need to pull the string harder. My sound machine changes pitch when the string is tighter or looser. When the string is tighter, the vibration goes faster, so we have a high frequency. When I hit the strings harder or softer, the volume changes because I am changing the amplitude.
Ooh, amplitude. That's a crazy word. And the amplitude describes what? Do you remember?
The sound wave.
The sound wave. Very good. Round of applause.